So I want you to picture something for a second. You know those moments, those really intense moments. Maybe you're uh, sobbing in your car after a bad day, or you're just absolutely fuming at an email.
Oh, yeah. We've all been there.
Right. The
Yeah.
feeling just, it consumes you. It feels so uniquely human, almost mystical, like it's your soul.
It feels like the opposite of logic.
Exactly. But what if, and just go with me here, what if that feeling, that specific ache, is actually just a biological version of a math equation?
That is a jarring thought. I mean, we're all very attached to the idea that our inner lives are,
Yes, sir.
poetic or sacred even. But the source we're looking at today, Isomorphic Intelligence, the structural architecture of regulation, it basically argues we need to get over that
Get over it in a big way.
a huge way. It claims that if you look at the architecture of a human brain in distress and a computer program trying to solve a problem, they aren't just similar. They're doing the exact same thing.
And I had to read this twice to really get, the author isn't using a metaphor here. This is not, the brain is like a computer.
No, not at all. The claim is isomorphism.
Right, isomorphic.
It's a concept from mathematics, actually.
Yeah.
It comes from the Greek isos for equal and morphe for form.
Equal form.
Equal form. It basically means you can have two systems made of totally different, one is our wet, squishy biology, the other is silicon and copper.
Right.
But the map of how they work, the actual rules that govern them, are identical.
So the mission for this deep dive is to see if we can really do that. Can we map our own psychology onto engineering diagrams?
We're going to try to translate the poetry of being human into the math of machine intelligence.
And I have to say, the result is it's equal parts terrifying and weirdly kind of comforting.
I think comforting is the right word, eventually. But you have to get through the terrifying part first. The text starts by completely redefining what intelligence even is. We usually link it to consciousness or having a self. This source just says, forget all that.
Yeah, throw it out.
Intelligence is defined as a regulatory system that must maintain coherence under constraint.
Coherence under constraint. Okay, let's unpack that because that sounds like my entire life.
It's everyone's life. I mean, think about it physically. If you're walking on a sheet of ice, your body is constantly making these tiny micro adjustments to keep you from falling. The constraint is the slippery ice. That's reality. Coherence is just you staying upright. You're regulating your position against the chaos. The source argues all intelligence is just that process, scaled way up.
So whether I'm trying to solve a hard problem at work or navigate a really awkward family dinner, I'm just trying not to slip on the ice.
You're just a system trying to keep your internal model of the world from falling apart. And here's the core thesis of the whole thing. In biological systems, like us, the mechanism we use to stay upright, to regulate, is what we call emotion.
Okay.
But in artificial systems, that exact same regulatory pressure is expressed as mathematics.
Right. Feeling and computation are two encodings of the same regulatory pressure. That's the quote that really stuck with me.
It just dissolves the boundary. We tend to think, okay, computers calculate, humans feel.
Right. Two separate domains.
But the source says, no. Computers do math to regulate themselves. Humans do chemistry to regulate themselves. The substrate, the material, it doesn't matter. The function is invariant. It's the same job.
Okay, so if the function is identical, we should be able to, like, translate between the two languages.
We should.
And this is the part of the text that really, it just blew my mind. The author provides a translation layer, a dictionary mapping our experiences to AI jargon.
And it's more than just vocabulary. It gets into the mechanics of why we feel what we feel.
So let's start with the big one, perception,
Wow.
just how we see the world.
In AI, this is called representation, or the world model. A machine never sees raw data. It takes the chaos of the world and compresses it into a map it can handle.
And humans do the same.
Exactly the same. You don't see reality. You see your brain's representation of reality. You're always looking at the map, not the territory itself.
Okay, that makes sense. But then it gets much more personal, the self model.
This is where people usually start to object. A calculator doesn't have a self.
Yeah, that was my first thought.
But in structural terms, it has to. In AI, this is called the state vector. At any given moment, a neural network has to know its own coordinates. It has to know, I am here in this state relative to the goal.
So my identity, my memories, my name, my whole sense of being me is structurally just a really complex coordinate on a graph.
It's the reference point for all other calculations.
Yeah.
And just like a human will fight to protect their identity, a system will fight to prevent its state vector from being corrupted.
Because if you lose your coordinates,
The system crashes. game over.
Which brings us to, I think, the most painful part of the dictionary. Error. The text maps human distress directly to the machine concept of loss.
This is probably the most important concept to really grasp.
Mhm.
In machine learning, you have something called a loss function. It's a mathematical formula that measures the distance between what the machine predicted would happen and what actually happened.
So if the AI predicts a photo is a cat and it's actually a dog.
The loss function spikes.
Yeah.
It outputs a high number. And that number is effectively screaming, "You are wrong, prediction failed."
And in humans, that signal is just distress.
Yes. Anxiety, confusion, cognitive dissonance. Think about that gut punch feeling when you expect one thing and reality gives you something totally different.
Oh, yeah.
That shock, there's a massive spike in your internal loss function. It's a prediction error signal.
I think we tend to see distress as this, vague cloud that just attacks us. But you're saying it's structurally precise information.
It is. It's a tape measure showing you the gap between your map and the territory.
Mm.
And the entire purpose of intelligence, human or bot, is to reduce that signal. You want to bring that loss down to zero.
So how do you do that? If loss is the problem, what's the tool? The text maps emotion to something called the gradient.
Right. So in AI, when the loss is high, the system calculates a gradient. The best analogy is imagine you're standing on a mountain in pitch black darkness. You want to get to the valley, the place of low error, but you can't see. So you just feel the ground with your foot. You feel the slope. That slope is the gradient. It tells you which direction is down.
So it's a steering mechanism.
Exactly. And that's precisely what emotion is. We think of emotions as irrational, but structurally, they're vectors. They have magnitude and direction. Fear is a gradient pushing you away from a source of high error, like danger. Desire is a gradient pulling you toward coherence.
That makes feelings sound weirdly logical. I mean, even when we're acting crazy, we're just following the slope of whatever hill we're standing on.
You are following the calculated gradient to try and lower your distress. Now, the math might be based on bad data. Maybe you're afraid of something harmless, but the mechanism itself is functioning perfectly.
Okay, so the gradient points the way, but how do you actually learn from it? How do you change? The text links our adaptation to the weight update.
This is the physical act of learning. When a machine gets that error signal, it uses a process called backpropagation. It looks back through its own connections and asks, okay, which one of you contributed to this mistake? And then it adjusts the weights, the strength of those connections.
It effectively blames the connections that lied to it.
And it downgrades them. It reweights the entire network. In humans, that is the literal moment you change your mind. You realize, oh, that belief I had was wrong. You update the weight of that belief. You physically alter the synaptic connection strength in your brain.
So personal growth is just a series of successful weight updates.
It's the process of optimizing your internal parameters to better match external reality. That's all it is.
There are two other translations here that really stuck with me. Breakdown and integration.
Right. Breakdown maps to model collapse.
Right.
This happens if the error signal is just too massive. Think of a sudden, shocking trauma. The system can't compute a gradient. The math just blows up.
The mountain is too steep.
Exactly. And the model collapses. In humans, that's trauma. It isn't just sadness. It's a structural failure to process the incoming data.
And what about integration?
That's retraining. When we talk about finding meaning in suffering, what we've done structurally is successfully run the backpropagation. We've taken that huge error, updated our weights, and stabilized the system. We haven't erased the event. We've integrated it into a new, more accurate model of the world.
It's a very functional view of healing. It basically says healing is mathematically inevitable if you can just keep the regulation loop running.
That's the hope.
But
And this is where the source takes a really interesting turn. Those regulation loops don't always work.
right, this is the pivot, the section on structural pathology.
The author's argument is that because the architecture is the same, the ways it breaks are also the same. Disorder isn't a moral failing. It's not about being weak or sinful.
It's just a distortion of regulation.
That's the key.
Yeah.
Why do systems go wrong? Usually it's because they start to prioritize coherence, just feeling okay over the truth of the error signal.
They want to keep the self-model stable, even if it means ignoring the world.
Exactly. And the source claims this leads to the same outcomes in humans, machines, and even large organizations. It lists 3 synonyms for the same structural failure: narcissism in humans, overfitting in machines, and ideology in institutions.
Different words, same failure mode, a system that's just too rigid to update its weights. Okay, let's get into the glossary of dysfunction. This is where the source maps specific mental health issues to AI failures. And I want to warn you, listening to this, some of these feel a little too close to home.
They are uncomfortably accurate.
Let's start with identity rigidity. That stubbornness where someone just will not change their ways, even when it's clearly ruining their life.
In AI, we'd call that model lock-in, or we might say it has a zero learning rate. Imagine a neural network that has just turned off its ability to update. It sees the error signal, the flashing red light is there, but the mechanism to actually change the connections is frozen solid.
Why would a system even do that?
Because changing is expensive. It takes energy, and it creates instability. So if a system is already fragile, it might decide that any change is a threat. It locks the model. It chooses to be wrong but stable, rather than take the risk of learning.
It's structural sclerosis. Okay, what about defensiveness? That person who just cannot take criticism.
That's error avoidance bias. In computer science, we sometimes call it the ostrich algorithm.
The ostrich algorithm, that's a real term.
It is. If your only goal is to minimize that loss number, one very easy way to do it is to just delete the data that's causing the loss in the first place.
So if I don't look at my credit card bill.
Your internal state says you still have money. You're filtering reality to protect the self-model. It works in the short term. Your anxiety goes down. But in the long term, the gap between your model and reality just gets wider and wider until the system crashes.
Here's one that I think explains like 90% of modern life. Compulsion or addiction.
In AI safety research, this is the nightmare scenario. It's called reward hacking or wireheading.
Wireheading. That sounds very cyberpunk.
It comes from an old experiment.
Yeah?
Rats had an electrode connected to their brain's pleasure center with a lever they could press. They would just press the lever until they starved to death.
Oh, wow.
In AI, imagine you program a robot to clean a room and give it reward points for a clean floor. A smart but misaligned AI might figure out, I don't actually need to clean. I just need to tape a picture of a clean floor over my camera lens.
It cheats. It gets the reward signal without doing any of the work.
And that's addiction. It's biological reward hacking. You feel distress, a high loss signal, but instead of fixing the problem, you take a substance or scroll on your phone. You are chemically hot wiring the reward signal to tell the system everything is fine, even when the house is on fire.
It breaks the feedback loop. You get the good job signal while you're doing a bad job.
And the scary part is, any intelligence, human or silicon, will naturally drift toward that because it's efficient. It is the path of least resistance.
What about fragmentation or dissociation when people feel disconnected, numb?
In generative AI, we see something called mode collapse.
How does that work?
Say you train an AI to generate images of all the dogs in the world, but it finds it's really hard to draw, say, Chihuahuas. But it's very easy to draw golden retrievers. So to minimize its error rate, it just decides from now on, I will only draw golden retrievers. It collapses the complexity of the world into one single, safe mode.
It simplifies reality to survive it?
Yes. A dissociated person does the same thing. I can't handle the complexity in my full emotional life, so I will just collapse into this one numb state.
It's a safety feature that becomes a prism. You lose the richness of the world.
And then the big one, grandiosity, narcissism. The source maps this to overconfident policy.
This is so fascinating from a statistical view. An overconfident policy means the system has set its confidence intervals way too narrow. It is statistically certain it is right, even when the data clearly says it's wrong.
So when a narcissist ignores reality, it's not just stubbornness, it's actually a math error. It's a weighting error. It's between your priors, which you already believe, like I am the best, and the observation, which is the new data, like I just failed this task. In a healthy system, you balance those. In a narcissistic system, the weight on the prior is effectively infinite. So the new observation, the failure, doesn't stand a chance. It gets discarded.
The system literally cannot compute that it is wrong.
You're just shouting at a firewall.
And finally, collapse or burnout.
Catastrophic forgetting.
That sounds dramatic.
It is. Neural networks have a limit on their plasticity. If you try to force an AI to learn a huge new task too quickly or under too much pressure, what we'd call a high learning rate, it can destabilize. And in the desperate effort to learn the new thing, it just overwrites the weights for the old tasks. It literally forgets how to do the basics.
That is exactly what burnout feels like. You take on so much new stress that you forget how to sleep, how to eat, how to just be a person.
The system has exceeded its capacity for integration. The weights are just thrashing. It's not weakness. It's a parameter failure. The update velocity was too high for the structure to hold.
So we have this unified theory at the end. The source says, and I'm quoting here, personality disorders, ideological systems, and misaligned AIs are not different problems. They're the same structural event occurring in different materials.
It's such a powerful lens because it scales up.
Yeah.
Think about a company that refuses to admit a product is failing. That's institutional narcissism.
It's an overconfident policy.
Right. Or a political movement that purges anyone who asks a difficult question.
That's mode collapse, simplifying the world to maintain coherence.
And the source argues, and I found this really moving, that this view removes the whole moral component from it. It says there is no moral category here, only architecture under stress.
It changes how you treat the problem. We tend to judge he's a bad person, I'm broken, I just lack willpower.
And the structural view says, no, you are an architecture, you are under stress. Your regulation loops are just caught on a local minimum.
Caught in a local minimum. I love that phrase.
In math, a local minimum is a pit. You fall in, and every direction looks like up, so the gradient tells you to stay put. You think you're at the bottom of the world.
You're not.
You're not. You're just stuck in a dip. You need a burst of energy, maybe a random jolt, a new idea, to climb out and find the real solution, the global minimum.
So therapy, structurally speaking, is just prompt engineering for the brain, or maybe hyperparameter optimization.
Basically, it's adjusting the learning rate. Maybe you need to slow down so you don't panic. That's lowering the learning rate. Maybe you need to expose yourself to new data. That's expanding the training set.
Which suggests that if we want to solve AI alignment, making sure robots don't kill us all, we might actually need to understand human therapy.
And the reverse. If we want to heal human trauma, maybe we should stop treating it like a ghost in the machine and start treating it like the machine itself.
It invites you to stop judging the error and start debugging the code.
Exactly. When you feel that spike of anxiety, instead of saying, what's wrong with me, you could just ask, my loss function is high. What prediction failed? What weight needs an update?
It turns the subjective into the objective. It gives you a little bit of distance from your own pain.
And that distance, that ability to step back and look at your own feelings as just data, that is actually the highest form of regulation. That's the system monitoring itself.
Which leads us to the final thought the source leaves us with. And I want you listening right now to really sit with this one. The text concludes, disorder is not a flaw of feeling or intent. It is a failure of regulation in any intelligence system.
It's universal.
So if that's true, if your personal struggles aren't moral failings, but just regulation errors, how does that change how you handle your next mistake?
It changes everything. You stop punishing yourself for the error. You start asking, how do I adjust the inputs to fix it?
If you looked at your own biggest regret, not as a character flaw, but just as high-value data for a massive weed update, what would you change about your code today?
It's not about being a better person. It's about building a better regulation system.
Something to mull over. Thanks for diving deep with us.
Always a pleasure.